Okay, we're going to do the second part of that dihybrid cross from the previous video. And so in part B here, I just copied it over to a new screen, a plant that is heterozygous for flower color and seed shape, and a plant having white flowers and is heterozygous for seed shape. That's the cross. And so once again, let's just take one parent at a time. So the first plant is heterozygous for flower color and seed shape. So that actually matches the genotypes that we used before in part A. So we have the, let's see if we can get my pen here. We have the red flower color, the red allele, the capital R allele. My stylus, there we go. All right, so there's the heterozygous for color and heterozygous for shape. There's parent number one, okay? And then we have a plant having white flowers. So those are two little R's. I know they're not small, but, and then heterozygous for seed shape. So that is one of these again. Okay, so here we have a little bit of a different genotype in parent number two. But we're going to do the same thing that we did last time, which is to identify all of the different combinations of R and S on both sides. Okay, so over here on the left, this is going to look identical to what we did in part A. Oops, that was a mistake. We have capital R and capital S. And you can write these in any order, but this is kind of the convention here. You know, you start with the first letter and do both capitals with either one, and then you make that lowercase and do the same. It just kind of keeps everything in the same spot for a lot of these problems. Okay, and I'm going to circle them again. Make sure we don't split those alleles up anymore. And then now on this side, you'll notice that we're going to end up with something a little different than we did before, because this parent, at least for the R allele, is homozygous. Okay, and so all we have are two little R's. Now, there are two alleles there, but it doesn't really matter as far as which one, because they're both the same. So the R and S combinations on this side are going to be a little R with a big S and a little R with a little s. All right, now I could, because let's say that this little R is the first one, okay, there would be two more alleles. I'm just going to write them out, and then I'm going to show you something here. I could just go ahead and do the same thing, okay? But these are the same, and these are the same. So I really don't need to write those twice. Now, if I did, I would end up with a 4x4 again, and I'd have all that stuff in the middle. But I'm going to simplify this one a little bit, okay? I'm going to, if I can get my eraser back. Here we go. I'm going to take these two away because I don't need to write these twice. I'm only going to consider how many different possibilities there are. And these are the only two different possibilities for parent number two. I can have a small r with a capital S, and I can have a small r with a small s. So by not being redundant with those, I'm going to be able to shrink the size of my table, which is good news, all right, because we wouldn't have to work with all of those 16 squares like we did before. Now remember what I said is once we have these combinations, the dimensions of the table are laid out for us. In part A, we had 4 on each side, therefore we had a 4x4 table. Now we have 4 on one side, 2 on another, so now we have a 4x2 or a 2x4. And it doesn't matter if you set it up horizontally or vertically. Either one is correct. I'm going to come down here since we do have room. And I'm going to set up a horizontal 4x2. And what I mean by 4x2 is we have, in this case, 4 columns and 2 rows. All right, so we're half the size of the table that we had in part A. Okay, so we put the combinations here, and we're going to put these two over on this side. Now, the reason why I did not have to do to write these twice is because if I extended these down, what I would essentially be doing is just writing this whole table over again, okay, and doubling the numbers, okay. It's kind of like 2 out of 4 is the same as 1 out of 2, okay. So instead of saying 4 out of 16, we can say, you know, the 1 out of 4. All right, so we can already reduce it. Okay, so let me get rid of that arrow there. Let's go ahead and fill in. All right, so I'm keeping the R's in the front. Oops, that one was wrong. This should be a little S over here. And this took a lot less time than the other big one. Okay, now, as we did before, there's not as many to count, but considering the genotypes that we have, being red and smooth, red and wrinkled, white and smooth, and white and wrinkled, we can go in and kind of count those up again if we wanted to do that, which we could do. So let's just do red, smooth. Let's see if I can write this a little faster. And I'm not going to write out the incomplete genotypes, but if you remember, you know what you're looking for each one, okay? The dominants, the reds and the smooths have to have at least one dominant allele. The other one could be either or. And then the white and the wrinkled, those recessive phenotypes, have to have 2 recessive alleles. Okay, so red smooth would be, I'm just going to cross out this time, this would be a red smooth, this would be a red smooth, and this would be a red smooth. So here I've got 3 of those, and this is out of 8 now. All right, now we're looking for a red and wrinkled. Okay, so that's a capital R. The wrinkled is 2 little s's, so I have got 1 of those. Let's see, is that right? Yes. I feel like I'm doing something wrong here. Yeah, oh no, okay, I know what I'm doing. Okay, so this is 1 out of 8. Okay, then we need a white smooth. So white smooth is here, here, and here. And so that's going to be 3 out of 8. And then we have our lone white and wrinkled is a 1 out of 8. Okay, so there are our proportions for this table. Okay, and then so with the dihybrids, there's really kind of a lot of possibilities that we can have as far as what genotypes we start out with, and therefore what the table is going to look like. It can be as big as a 4x4. It doesn't have to be as 4x4. Let me just do something down at the bottom here real quick. If I wanted to cross this together, okay, completely homozygous dominant times homozygous recessive for both genes, okay, what I would essentially have is this and that. Okay, that little funny thing is an S. And you know what my table would look like? I'd have 1 and 1. Okay, if we can even call it a table, it would be 1 box big. It would be a 1 by 1. And all of the offspring would have that genotype. Okay, you can see the less variation there is in the parental genotypes, okay, like, you know, this one only has 2 different alleles, this one only has 2 different alleles, not much variation as far as within parents. there are going to be fewer possibilities coming out of that. In part A, when both parents had 4 different alleles each, the possibilities became bigger. Okay, they were more numerous then. So you just, again, you have to work it out. You have to find on each side how many of those combinations you can pull out, and that will show you what the table should look like. Okay, so that is the dihybrid cross.